Hey everyone, welcome back to the College Algebra playlist. In this video, I want to continue our discussion of functions. All right, we're going to look at some graphs of some functions and characterize the functions just by looking at those graphs. All right, so let's dive into it. Okay, here we go. The first thing we'll look at is increasing and decreasing functions. All right, a function f is increasing on an open interval if f of a is less than b for any two input values a and b in that given interval where a is less than b. All right, so if we read a function from left to right, like it's a sentence in English, right, a is less than b. Okay, so as we increase the x value, the output value increases as well. All right, f of a is less than f of b. So that's what it means for a function to be increasing from left to right. All right, and a function f is decreasing on an open interval if f of a is greater than f of b for any two input values a and b in the given interval where a is less than b. All right, so as you move from left to right with this type of function, you move from left to right and you get the output values decreasing, right? F of a is greater than f of b. All right, so these definitions are fine, right? We can use them to identify where a function is increasing and decreasing, all right? But what's easier is to actually take a look at a picture, all right? Let's look at a concrete example, all right? With a lot of things in math, it's easier if we have a picture, all right? So let's take a look at this function here, all right? This is the function f of x equals 1/4 x cubed minus 3x, all right? We don't care about the formula as much as we care about the behavior of the graph, all right? Let's talk about the behavior of the graph, all right? We can see that it's increasing on the interval negative infinity to negative 2, all right? So these are all the x values in between negative infinity and negative 2, all right? We can see that the output values of this function are increasing on that interval, all right? Remember, this curve is made up of an infinite number of coordinate points, and what it means for it to be increasing is that the y values of those points are going up as you move from left to right, all right? And then we can see that the function is decreasing on this interval here, the interval negative 2 to 2. All right, so the output values are going down as you move from left to right. And finally, this function is increasing on 2 to infinity. All right, notice that negative 2 and 2 are not included in any of these intervals, right? They're not included because at those points, right, at this point, this is where the function is neither increasing nor decreasing. And same thing for this point. All right, so you don't include them on the intervals. All right. So let's move on to a different example. All right, let's identify the intervals on which this function appears to be increasing. All right, it's decreasing here, and then it goes up, and then it goes down, and then it goes up again. All right, so the function is increasing on 1 to 3 as well as 4 to infinity. All right, so these are my two intervals that I'm looking for. All right, let's move on to something called local extrema. All right, local extrema, what does that mean? Let's take a closer look at these points here, right? The blue point and the red point. All right, an output value where a function changes from increasing to decreasing as you move from left to right is called a local maximum. All right, so extrema, right? We're looking at the extreme ends of the spectrum, right? This is a local maximum. All right, so look at this point here, and we can see that this is the spot where the function switches from increasing to decreasing. All right, so this is a local max. All right, and then when we look at this point, we can see that this is the point where the function switches from decreasing to increasing. All right, so this is called a local minimum. All right, there's a local minimum at 2, negative 4. All right, that's where the function switches from decreasing to increasing. Okay, So these definitions are fine, but they're a little bit informal. All right, what I want to do is take a look at local max and local min one at a time and write down a more mathematically rigorous definition. All right, a function f has a local max at x equals b if there exists some interval a to c where b is in between a and c, such that for any x in that interval, we have f of x is less than or equal to f of b. All right, so think about the word local. All right, what we're doing is we're zooming in on this point, right? We're zooming in on this part of the graph. And we're saying that there's some interval, right? Consider the interval -3 to -1. For any x in that interval, we have this maximum here, right? We have f of x is less than or equal to f of -2 in blue. All right, the output value there is 4, and the output value of all the other points on this interval are going to be less than or equal to 4. All right, so it's a similar story with local minimum. All right, this is a local max, and this is a local minimum. Right, why is that? Let's look at this definition. A function f has a local minimum at x equals b if there exists an interval a to c with b in between a and c, such that for any x in the interval, we have f of x is greater than or equal to f of b. All right, so let's look at the concrete example interval 1 to 3. All right, for any x in that interval, we have f of x is greater than or equal to f of 2. Right, f of 2 is -4. All right, so all the y values on this interval, right, they're going to be greater than or equal to -4. All right, so this is a local minimum. All right, we zoom in on the graph and we call it a local minimum. All right, here we're asked to find the local maxima and minima of this function, right? And we're using the plural forms of the words, right, because there could be more than one, right? More than one local max or local min. Okay? This point here, -1, -2, all right, this is where the function switches from decreasing to increasing. All right, so this is a local min. And then at this point, this is where the function switches from increasing to decreasing. All right, so this is a local max. All right, there's a local max at 1, 2, and there's a local min at -1, -2. All right. Next, let's talk about something called absolute extrema. All right, absolute extrema. The absolute maximum of f at x equals c is f of c, where f of c is greater than or equal to f of x for all x in the domain of f. All right, so we're not looking at a small mini domain like we were before, right? We're not zooming in on the graph and calling it a local max. We're saying that it's the absolute max, right? It's bigger than every other value in this function's domain, right? The output values we get for any point in the domain, right? F of c is going to be greater than or equal to those points, all right? So this is an absolute max. 2 is the biggest output value for any other output value in this function, all right? And the absolute min is where f of d is less than or equal to f of x for all x in the domain of f, all right? So there's an absolute min on this example function here, right here at 0. X equals 0, we get y equals -2. And all the other y values of the points on this graph are going to be greater than or equal to -2. All right, so this is an absolute min. All right, here let's try an example where we're asked to find the local extrema and absolute extrema. All right, let's differentiate between the two. All right, local extrema and absolute extrema are two different things. All right, let's take a look at this graph. This point right here, the function is switching from increasing to decreasing. All right, so this is a local max. All right, we have a local maximum at -2, -2, 4. All right, and then this point, right, the function switches from decreasing to increasing. All right, so this is a local min. All right, but these values are not absolute, right? There are y values on this graph that are bigger than 4, and there are y values that are smaller than 1. Okay, and we can see that at this point up here, right, this green point, this is going to give us our biggest y value for any other point on this curve. All right, so that means that there's an absolute max right there at 2, 5. Okay? And finally, with this purple point, we can see that all the y values are going to be greater than or equal to -2. All right, so this is an absolute min. All right? So that's how we can talk about the behavior of graphs and identify local max and min and the absolute max and min as well. All right, that does it for this video. Thank you for watching, and like and subscribe.